Okay, so now basically now the point that I wanted to make in the previous video, and I forgot what I was talking about, is that when you have a function like this, for example f of x is equal to 4x over 3x plus 4, you can see that this function is not defined at x is equal to negative 4/3, which means that it will give you a vertical asymptote here and a horizontal asymptote as a result here, and that means that this function is not basically is good enough for all of the elements that we have here, meaning that all of these elements, of course, will be mapped to some elements in the codomain of the function. But the problem is that, as you can see, even based on the definition of this function, you do not simply know what elements in the codomain of the function have been mapped to. That's the problem here, and that is, and this problem, as this problem arises, then the range of f becomes some set which is not the same as the codomain of f, and as a result there are some elements here in the codomain that are left out. For example, this element here, negative 1 and 1/3, is just simply not the image of any of the elements in the domain of the function. So what that means is that this function is good enough for all of the elements that are indicated in the domain of the function. You know that all of these elements will be mapped to some elements in the codomain of the function, right? But it gives you no promise to get you back from where you started, right? Meaning that it takes you that it tells you that I'm going to take you from here to the codomain, but it doesn't give you any promise as to basically it doesn't give you any promise, like, for example, if you pick any element in the codomain of the function, that I'm going to be able to get you back from there to the domain of the function. Some elements, of course, well, there is no problem with that. For example, the function tells you that, for example, if you want to go from, for example, this element to the codomain, which is basically this thing over here. So this is domain and codomain. So it tells you that basically if you want to, any element that you pick here, except for this horizontal, for this vertical asymptote, any element that you pick here, I'm going to be able to take you from here to the codomain, meaning that this is basically what happens. Or pick this element, the function takes you there. Pick this element, the function takes you there, and so on and so forth. Or pick this element, the function takes you here, right? So it's going to promise to take you from all of these elements to the codomain, right? And it's telling you beforehand that, well, this is where I have a problem, and I cannot take you from here to anywhere. At this point, which is, for example, x is equal to negative 4/3, from this point, if you're here, you're on your own, I cannot do anything for you. But then it does make all of those promises, and it does actually deliver on those promises, but it doesn't tell you anything about getting back. Meaning that it doesn't promise that from any element that you pick in the codomain of the function, that the function will be able to get you back to the domain. And so, for example, it so happens that, for example, for this element y is equal to 4/3, that the function doesn't have any mechanism to get you back to the domain of the function, which is of course happens to be the same point which is excluded from the domain of the function, right? And for the same reason, then we have to differentiate between the codomain of the function and the range of the function when we want to find the inverse of functions that are not onto. If the function is onto, of course there is no problem. If the function is onto, then of course all of the range of the function is the same thing as the codomain of the function. You can get from basically using the function from any element to the codomain, and any element that you pick in the codomain, the function is going to help you get back to the domain. So you have no problem there. But this function over here is 1, 1. We have no problem with that, but it's not onto. And so since it is not onto, I have to differentiate between the range of the function and the codomain of the function when I want to calculate basically the inverse of the function. And that is basically the point that I wanted to make in the previous video, and I actually forgot that. Now let's see how we can solve this problem using all of this information. So now the question is basically this, and so basically you have this function, and this has been excluded from the domain of the function, and the codomain is R, and it's defined as basically this function here, and we want to know basically, and you can see over here that G, which is supposed to be the inverse of f, goes from the range of f, meaning that, well, this over here is the codomain of f. This is the codomain of f, not the range of f. But G, the inverse of f, goes from the range of f back to the same set that you have here. So that is the important point that needs to be understood. Now, so for the same reason, we can argue that for the same, basically to solve the problem, we can argue that basically it is given that as the solution, we can say that it is given that f is a function from r minus negative 4/3 to r, defined by f of x is equal to 4x over 3x plus 4 over 3x plus 4. Now if I want to find the inverse of this function, what I can do is that we can say that let y be an arbitrary element of the range of f. Now, if y is an arbitrary element of the range of f, since it is in the range of f, that means that, well, you got there using the function, right? When you have a function, basically when you have some function, for example, when you have some function from some function f from a to b, there might be some elements here. For example, let's say that you have these elements, and there is some mapping here to this element and to this element and to this element. But then still there are all of these elements here that have not been mapped to. And this is still a function. Let's say that these are some elements here and you have no problem. Now, basically this set over here, this set is the set of range of f. Range of f. And this is basically f, of course. So, of course, you can see that you can appreciate the fact that you will appreciate the fact that basically these elements, of course, you got there using the rule of the function itself. That means that using the rule of the function, you can go back. And we are not talking about these elements here, this one, this one, this one, this one. We didn't actually get there in the first place, right? But the elements that we got to using the rule of the function, we can use the same rule to get back to the domain of the function, right? Now, what that means is that when I say that let y be an arbitrary element of the range of f, then based on that you can say that then there exists some x belonging to this set, basically all of our x's belong to this set, belonging to r minus negative 4/3, such that basically y is equal to f of x, right? Y is equal to f of x, meaning that there is some x in this set, r minus negative 4/3, that has been mapped to that f of x, and that f of x we have called it y. So now if basically y is equal to f of x, I can write this as y is equal to 4x is equal to 4x over 3x plus 4. And what that means is that you can cross multiply. Now, y is equal to 4x divided by 3x plus 4. What that means is that now you have your basically what this equation tells you or gives you is that you have your domain here, you have your codomain here you have your x's, here you have your y's. And you have, for example, x1, x2, and so on and so forth. You have y1, y2, and so on and so forth. So what this equation tells you is that it tells you that basically to get to any y, or what it tells you is that basically for any x, what sort of y you are going to get. Meaning that I can say that so I'm going to set x is equal to 1, and for x is equal to 1, y is going to be equal to, for example, 4 times 1 over 3 times 1 plus 4, right? And then you will get some numbers here. Or for x is equal to 2, you will get some y over here, and so on and so forth. That means that this equation is telling you for any x that you pick, what sort of y you are going to get. Now, what I need to do is that I need to know for any y that I pick, what sort of x I'm going to get, right? Because I want to get back here. Which means that basically then y is equal to 4x over 3x plus 4. Then I need to basically, if I want to know for any y, what sort of x I'm going to get, then I need to calculate x in terms of y, right? I need to calculate x in terms of y. And for that reason, I need to cross multiply here, meaning that put these x's together and then calculate that in terms of y, basically. So then, if I cross multiply here, I'll get 3xy plus 4y is equal to 4x. Since I want to find my x's put together, then I write 3xy minus 4x is equal to negative 4y. And so basically, if I take an x basically take that out and write 3y minus 4 is equal to negative 4y. And then I can write this, to calculate x, I can write x is equal to negative 4y divided by 3y minus 4, which I can write as multiplying numerator and numerator by a factor of negative 1, I'll get 4y over 4 minus 3y. So that is going to be that tells me for any y what sort of x I'm going to get, and which is basically the reverse function, or the inverse of what we were doing using f. Using f, we were going from this set to this set, but then if I can use this equation now in a more useful way, I will have found a way to get from these elements back to these elements, right? So now that I know that basically x is equal to 4y over 4 minus 3y, and that I know that that is the case, then what I can do is that we can define some function g, which is supposed to be basically the inverse of f. So let us define some function g, which goes from, and y basically over here represents an element of the range of f, right? So then basically g has to go from this set back to this set, meaning that you have to go from range of f to the domain of f, right? So the range of f is basically the range of f is basically the range of f, and the domain of f was basically r minus negative 4 thirds. And I define this function as for example f of y, g of y is equal to 4y over 4 minus 3y over 4 minus 3y. Now, in order to make sure that this function is actually the inverse of f, in order to make sure that basically g is the inverse of f, we need to show that basically g of is the same thing as I of basically the domain of f, of course. So I of x, which is basically which is the same thing as I of domain of f, right? And we also need to show that basically FOG is I of basically I of basically range of f, of course. Range of f. Now I cannot say the whole codomain of f because G has been defined as basically the as G has been defined as basically the domain of G has become the range of f and not the whole codomain of f, right? Now, so now we need to basically show that these two are true, right? So if I write, let me write these equations down here. Now f of x was equal to, I know that f of x was equal to 4x over 3x plus 4. 4x over 3x plus 4, and g of y was equal to this function over here, somewhere we wrote it. G of y was 4y over 4 minus 3y, right? So these are the two functions that we have. And now if using these two functions, if I calculate GOF, that gives me basically, so you need to take basically the function g, and wherever you see the variable, that is the same thing as actually GOF of x basically, right? And you can write that as g of f of x. That means that in the function g, wherever you see the variable, you have to substitute that with the whole function f of x. So this is equal to basically, so in the function g you have 4y, so here you have the variable. Instead of that, you need the whole function f. So 4 times, for example, 4x over 3x plus 4, and over here I have 4 minus 3 times y, which is again 4x over 3x plus 4. And now let's do the algebra here. This is the same thing as 4 times 4 is equal to 16. 16x over 3x plus 4. And over here you have 4 minus 12x over 3x plus 4. 3x plus 4. And then I can write this as 3x plus 4, 16x, and over here I can write 3x plus 4, and 4 times basically 4 times 3 is equal to 12x plus 16 minus 12x and as you can see, you can simplify these two. And you will get 16x over 16, which is equal to x, right? So which means that basically GOF is equal to I of x, or I of the basically you can say I of domain of f. You can say I of domain of f, which is the same thing as I of basically this set over here, which is r minus negative 4/3. R minus negative 4/3, right? Now the next thing that we need to calculate is basically FOG, and we need to show that FOG is equal to I of range of f. We need to show that FOG is equal to the I of range of f. Range of f, right? So in order to show that, so I can simply write calculate FOG. FOG is the same thing as FOG of y, which is the same thing as f of g of y, and f of g of y is the same thing as, so in f where you see the variable, write g of y. So f is basically 4x over 3x plus 4, 4x over 3x plus 4, 3x plus 4, that is equal to f of x, and g of y is equal to 4y over 4 minus 3y. 4y over 4 minus 3y. That is g of y. So then I can write this as basically in f, so 4 times basically the function g, and the function g is 4y over 4 minus 3y, and then basically you can write here so what am I calculating? I'm calculating f of g of y, right? So in f, so now I have to write 3 times this function, which is 4y over 4 minus 3y, and plus 4, right? So that is equal to so I can write this as basically 4 times 1 is equal to 16y over 4 minus 3y, and then over here I have 12y. I have 12y over 4 minus 3y plus 4, and that is equal to basically 16y over 4 minus 3y, and over here I can have basically 4 minus 3y, and that's 12y plus 16 minus 12y, and then these two will be cancelled out. These two will be cancelled out. You have 16y over 16, which is equal to y. So that means that FOG is actually the I of basically the range of f, right? That means that FOG is equal to I of range of f. And so what that means is that, and we also showed that basically GOF is equal to I of some set which was the domain of f, which was r minus negative 4/3, right? And you can say that thus G is the inverse of f, that is f inverse is equal to G, and hence the inverse of f is the map. The inverse of f is the map G from basically from range of f to basically to the set which is r minus negative 4/3, right? Which is given by G of y is equal to 4y over 4 minus 3y, right? And so 4y over 4 minus 3y would be choice B is correct, right? So that is, I suppose that was question number 14, right? That was question number 14, right? Okay, so we are done with the exercises, and in the next video we will talk about binary operations. I'll see you in the next video, and thank you.